All right, so from here, I'd love you to experiment with different sided shapes. Let's try a 12. Now, I think 12 times 3 is 36. So 12 times 30 will give me that extra 0 I need to make 360. So 12 times 3 is 36. I know that. So 12 times 30 should be 360. Let's see if I'm right. I'm going to take Scratch over here. And I'm going to have 12 sides to my shape. And what you'll notice is the more sides you have, the more circular your shape becomes. So now I'm going to double 12, which means I can half 30. And I'm also going to make my sides slightly smaller because I know that my shape is going to get bigger the more sides I have. So here we've got 24 sides, and I'm doubtful if I'm going to squeeze it on the screen here. I might just scrape it. No, it's going to distort. Basically, if Scratch comes off the screen, he'll try his best to draw your shape, but it will distort it and won't meet up on the ends. Now here's something I'm going to add in, and that is a bit of initialization. Remember, initialization is kind of like setup, like starting. So I always want Scratch to start in the same position. And actually, I don't want Scratch to start in the middle. I want Scratch to start somewhere over here, because we're going to draw our shape. Now Scratch looks like he's going to start at the top. So I want Scratch to be kind of up here. So I'm going to change my y-axis. Don't worry if this doesn't make sense. If it does, you know what I'm talking about. To about 60, and let's see what happens here. All right, so Scratch is going to start from up there. It's not high enough still. So this is trial and error. We do this a lot in computing. Let's try 120. Yep, 1, 2, 0. So Scratch starts higher up now and should, in theory, draw me a 24-sided shape. And after each straight line, so these are all straight lines being drawn, Scratch turns 15 degrees. We can see that down here. So I've got 24 lines. And it looks like a circle, doesn't it? But actually what we've got is 24 straight lines. So I'm just doing this to show you that the more sides we have, the more we start to look like a circle. So if I went to 36 here, or 48 here, we'd really start to look like we had a circle. But actually what we've got is 24 straight lines, and we're turning 15 degrees. That's how much we're turning after each straight line. But let's bring it back down, because for the sake of our shapes today, 6s and 8s work really, really well. And we can make them a bit bigger too. So I'm going to say 55 steps for each side. And I'm going to put my number of degrees to 60 here. Okay, so 6 6s are 36. 6 60s, 6 zeros, is 360. So let's try it. Let's test this one out. Here we go. Nice. Okay, so we've got a hexagon. Let's try an octagon here. So I'm going to say 8 sides, and you can do this in Google if you like. You just simply go to Google and you say 8 divided, and we use the / for this. 8 divided by, let's do it this way. 360 divided by 8. And actually, it even gives me the answer before I press go. So it's telling me 45. Let's press go anyway, because then the calculator comes up. We can use that again in a minute. So we know that 360 is our magic number divided by 8. Then we need to put 45 in here. Okay, and this will give us what's called an octagon. Let's create a slightly bigger shape. I'm going to put 65. That's how many steps we're going to travel on each of our sides here. So 65 steps. And we've got an octagon, so that's 8-sided shape. At this point, I'd like you to experiment with that, okay? So go away now and see all the different size shapes you can do. I expect some of you will put 200-sided shapes in, maybe even 1,000-sided shapes, but anything over about 12 to 16 starts to look like a circle, okay? So I'm going to save you a bit of time there. And the formula one more time is 360 divided by number of sides. Where did it go? Okay, I've lost it. Here it is. Ah, there we go. So 360 divided by the number of sides. So for a triangle, it's divided by 3, and it's 120. For a square, it's 360 divided by 4, and 90. A pentagon, 72. A nonagon, 40. If you like, it'd be really cool for you to write this out. So you get your 360 and divided by 3. You can even do it like I have in a spider chart format. So it would be like this. 360 in the middle. And then you can do 3, 4, 5, 6, 7. It'd be fantastic if you go all the way up to 10, even 11 or 12. Let's do it. 10, 11, and 12. And if you can work out the degrees that we need to turn to create each of these polygons. So, off the top of my head, I can remember these. So we're dividing each time. We're saying, how many times does 3 go into 360? It goes 120 times. How many times does 4 go into 360? It's 90. And see if you can complete this.